Welcome to 5083, Finding and Graphing Relationships. So after this lesson, we should be able to find the pattern in a given set of numbers, use a pattern to create a set of inputs and outputs, and then graph those inputs and outputs on the coordinate plane. So we are going to be doing a little bit with ratios and proportions, connecting that to functions, and then extending that into geometry. So let's take a look. First, we need to remember that an input is the value that is substituted into an expression or a function. So if I know that I'm going to take every number and multiply it by 2, whatever number I put in to do that, that's my input. My output is the value that results from the substitution of a given input into an expression or function. So if times 2 is my pattern and I put in 3, I do 3 times 2 and my output would be 6. Remember, all of these should already be in your vocabulary notebook. This is just a quick reminder. And then pattern. A pattern is things arranged following a rule or rules. So in this case, if we look at the first one, the ones in blue, we have a rule of plus, or a pattern of +2, so 2, 4, 6, 8, 10. Then in the orange, we have a pattern of times 2, so 2, 4, 8, 16, 32, 64, 128. Right, so a pattern is kind of like how we go from one side to the other, or one number to the next. For our geometry, we have a coordinate plane, which is the grid formed by the intersection of horizontal and vertical lines, and it helps us locate different points. So like in social studies, when we're talking about maps and using longitude and latitude, you're using a coordinate grid. You have the y-axis, which is your 0 line for your vertical line. So it's your 0 line that goes up and down. So every y value on this line is 0. And then your x-axis is your 0 horizontal line. So every x value on this line is 0. Then your x-axis and your y-axis help you find your x-coordinate and your y-coordinate. So your x-coordinate tells you how far you can go left or right, and your y-coordinate tells you how far to go up or down. Notice it's x and then y, and the reason for that is because we have to go across before we can go up or down. So think of it like an airplane. Okay, so the airplane has to go across the runway before it can go up into the air. Or like if you're going to go scuba diving, you have to take the boat across the water before you can dive down into it. These two coordinates together make what is called an ordered pair. Those are how you find your points. The ordered pair of 0, 0 is going to be your origin. So that's where we always start when we're plotting points. We start at 0, 0. And then the x tells me from 0, 0, how far do I go right? And then how far do I go, or how far do I go left? And then how far do I go up, or how far do I go down? And then each of these axes makes a different quadrant. There are 4 different quadrants in a coordinate plane. We are going to be working predominantly in quadrant 1 for today. All right, so finding the pattern. So we need to remember that our x values are typically our inputs and our y values are typically our outputs. So x is what we put in and then y is what we got after we did that. So we're trying to figure out what was the pattern. What happened here? So it's kind of like the line is your function. What happened right here that made the 7 turn into a 14? Well, I could say that I added 7, but it has to work for all the numbers. So if I add 7 here, it doesn't work because 8 plus 7 does not give me 16. So back to the drawing board I go. I know that I could also do times 2. So if I multiply by 2, that gives me 14. Let's try with 8. 8 times 2 does give me 16. So try with the next one. 9 times 2 does give me 18. And 10 times 2 does give me 20. So I know here that my pattern is going to be my x value times 2. Sometimes your pattern isn't going to be as easily found, and it might not be found going from input to output. Sometimes you're going to have to be a little bit creative, okay? So taking a look, plus 2 doesn't work because it doesn't work all the way down. There's really no easy multiplication that allows me to know my pattern. But if I take a look here, I see that it's consistent. I see that if I do plus 7, I get to 14. Plus 7, I get to 21. Plus 7, I get to 28. And every time I add 7, I add 9 to my output. Because of this, I know that there is a pattern, okay? And I could type, or I could write out that when I add 7 to my x value, I add 9 to the y value. Okay. So this lets me know that there is a pattern. I could go through and find the mixed number that I could multiply by, but for right now, we're just looking to see that there is a pattern. All right, so this one, I'm actually going to give you the pattern. So the pattern is going to be your x value times 3. So I'll do the first one for you, give you the example. So I have 6, and when I multiply it by 3, I get 18. I want you to try 8, 5, and 11 on your own, and when you come back, check your answers. So you should have found that 8 times 3 gave you 24, 5 times 3 gave you 15, and 11 times 3 gave you 33. So once you have the pattern, which was times 3, all you had to do was replace the x value with what you saw on the chart. So I saw a 6, so I multiplied it by 3, and I got 18, so that was my output. And 8 times 3 gave me 24, that was my other output. 5 times 3 was 15, and 11 times 3 was 33. So now we're going to take this and we're going to actually turn these into ordered pairs. So in order to turn these into ordered pairs, all I have to do is take my input and my output and put them in an ordered pair. So to do that, I have to remember that my inputs are my x values and my outputs are my y values. And when I make an ordered pair, it's always x, comma, y. So here, 6 is my x, 18 is my y, and then I have to put them in parentheses. Next one, 8 is my x, and 24 is my y, and I put them in parentheses. I would like you to try the next two on your own. Go ahead and pause, and then when you're done, come back and check your answers. So you should have gotten 5, 15, and then 11, 33. Okay. I want you to go ahead and fill out your own on the bottom here. So choose your own input, find the output, and then create your ordered pair. So now we're going to go ahead and we're going to graph those ordered pairs. In order to graph those ordered pairs, I have to remember that I always start at the origin, which is right down here on your graph. And I have to remember that my x tells me left or right, and my y tells me up or down. Now, mind you, we're only working with positive numbers, so we're only working with left and up. So my first one is 618, so it tells me to go, I'm sorry, it's right and up. This is a D for down. It looks like a P. There we go. So here I start at the origin and I move over 6 places. So 1, 2, 3, 4, 5, 6. And now 18 tells me to go up 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have to count each one of those lines as I go up. Okay, so I can check that one off. So then the next one here, let's do 5 and 15. So it's a little bit easier for you to see while I'm counting. So I'm going to go over 5. So 1, 2, 3, 4, 5. Now I don't have to make those lines, but I want you to see how I'm counting. And then I have to go up 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then I plot my point. If you do make those marks, that's totally fine. Just make sure to go through and erase them so you know that they're not actually part of your answer. All right, so the next one is 8 and 24. So the nice thing is I know this spot right here is at 618. So I can go over 2 because this is 6. So then 7, 8. And then if this is 18, I need to go up 6 more. So 18, 19, 20, 21, 22, 23, 24. Right. And then nice and easy, this last one that I gave you, I know you made your own, is 1, 3. So I go over to the right 1 and up 3, and I plot my point. Now, the reason I put this here is because I wanted you to see if you noticed anything about the points that we plotted. So if you look here, if you draw a line from the origin and connect your points, you'll notice that they make a straight line. For right now, when we're working with our numbers, or when we're working with patterns, you need to know that if there is a pattern, it's going to give you a straight line. And this is very simple. It's going to get more complex from here. But for today, what you need to understand is if it's a pattern, if you get a straight line, you have a pattern. If you look at your table and you know the table creates a pattern and then you plot it and it goes like this, you need to check your plotting, okay? So if you know there's a pattern, you should get a straight line as your graph. So the next thing we're going to do is we're going to connect this to word problems. So we're going to read the problem. Kurt is trying to raise money for the United Way, so he proposed the following to the school. For every $20 raised, he will spend 2 minutes on the roof overnight. To show students how easy it could be to make Kurt sleep on the roof, you decided to make a graph that would show how many minutes he would spend on the roof for varying levels of donations. Okay, so taking a look at this is a little different. So what are they asking you to do? They're asking you to make a graph that would show how many minutes he would spend on the roof for varying levels of donations. So varying levels is kind of important here. So you're doing different amounts of donations. And it's important to know that every $20 gets 2 minutes. So for every tells us that we are going to have to multiply. Because every time somebody donates $20, he's going to spend 2 minutes on the roof. So taking a look at that, if you double the amount of your donation, that should double his amount of time on the roof, correct? Okay, so we're going to go ahead and we're going to take that into the next slide. And I'm actually going to erase so I can make this look a little bit nicer. There we go. Excuse me. So here I have our inputs, our outputs, and then we're going to make our ordered pairs. So that way you can make your graph. So if I put in $20, I get 2 minutes of Kurt having to stay on the roof. So if I double the amount of my donation, we said that doubles the amount of time. So if we look at this, we should see a pattern. When I put in X, my number is getting smaller, so I know I'm dividing, and to go from 20 to 2, I'm dividing by 10. Well, let's see if that works. If I put in 20 and I divide by 10, it gives me 2. If I put in 40 and I divide by 10, it gives me 4. So I know that my pattern is to divide by 10. So let's take a look. Let's pick, and we're not going to go crazy here with numbers that aren't base 10, but let's try $100. So if I donate $100, how much time is that going to make Kurt spend on the roof? If I take 100 and I divide it by 10, I get 10 minutes. So that ordered pair is 100 and 10. I also know though, like what if I only can donate $10? Well, if I can donate $10 and I divide by 10, that means he should spend 1 minute on the roof, right? And then let's go ahead and say $50 because we don't have anything here right now that has kind of like an odd number in the front. Well, I guess 10, yeah, but so $50 should get us 5 minutes on the roof. So now we are going to take those and we are going to plot them. And what will be nice is if I could take this over to the next screen with me, but it doesn't look like I can. All right, so we're just going to have to, you have those numbers written down. So here, I have to remember that my input, so my X values, was the amount of the donation. And that was in dollars. And then my output was time on the roof. And that was in minutes. So now here though, if I count by ones on this bottom line, I'm going to run out of space real quick. So instead of counting by ones, I'm going to go ahead and I'm going to count by tens. Okay, counting by tens is going to allow me to have more information in my graph. So this first one is going to be 10, and then 20, and then 30. Notice I'm only writing every other one though, because I don't want to run out of space. Okay, that doesn't mean that this isn't worth 20 or that this isn't worth 40. It just means that we are being a little bit, we're using our space a little bit more wisely. Okay, and then here I can still count by ones for my minutes because I have enough space. Okay, so I know the first one that I said was that if I gave $20, he would spend 2 minutes on the roof. So over to 20, up to 2. And then I'm going to go back and take a look. Oh yes, if I doubled the amount of time, so if we went to 40 minutes, that meant, or $40, that meant 4 minutes on the roof. I also know that we said if it was 50 minutes, he would spend $50, he would spend 5 minutes on the roof. Then we also said that if it was $100, he would spend 10 minutes on the roof. So 100 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my point. Okay, and then I also know that I put 1 minute would cost me $10. Okay, to double check, I can look and see, does this give me a straight line? It does, so I know that I plotted them correctly. I can also see that right here, this point that we didn't plot, it should tell me that if I donate $30, because I'm going down here to 30, that should mean he has to spend 3 minutes on the roof. All right, so what you're going to do is you're going to go through and you are going to do these 2 your turn problems. So you are going to go ahead, you're going to find the pattern, and then you are going to graph it. And then here, I want you to create a table using this word problem. When you come back to class, we're going to take a look at your work, and then we're going to try some of these other problems in class.